We will go through permutations and combinations. This is a small summary of what we will cover in section 7.4. So we have to see how to calculate factorials, how to calculate permutations, combinations, and also some applications involving permutations and combinations. This is the definition of the n factorial. N factorial is n times n minus 1 times n minus 2 times at the end 1. That means you have to multiply all the numbers up to this number. For example, 5 factorial is 5 times 4 times 3 times 2 times 1. This is 120. 7 factorial you multiply from 1 until 7. 10 factorial from 1 until 10, and so on. By definition, 0 factorial is equal to 1. So let's go to see how to calculate 5 factorial. I have the graphing calculator. So 5, then you go to math, you go to probability, and you go to number 4. Click enter, and then again enter. So this is the answer, 120. Let's go to calculate 10 factorial. So 10, same steps, math, probability, and then we go again to number 4. Actually later on we will see permutations, which is number 2, and combinations, which is number 3. So click enter, so 10 factorial, and this is going to be the answer. Next, let's go to see the difference between permutations and combinations. Let's assume that we have the set of PEN. That means we have 3 letters, and we want to see how many 2-letter words can we create. So we can have the words PE, PN, EN, NE, NP, and NE. So in the reality we have 6 possibilities. Now let's go to see the same problem. However, we have now 3 males, Paul, Ed, and Nick. So how many 2 men crews can be selected from this set? We may have Paul, Ed, Ed, Nick, and Paul, Nick. So the answer is going to be 3. Don't forget, Nick and Paul and Nick is the same person. So from these 2 problems we see that the difference is going to be the order. So for example, in both problems involve counting the number of arrangements of the same set taken 2 elements at a time. So in the first case the order of the arrangements is important, since PE and EP are 2 different words. In the second problem the order is not important, since PE and EP is the same person. As a result, in the first case we talk about permutations, where we take 3 objects 2 at a time, and in the second case we talk about combinations of 3 objects 2 at a time. We will use the letter N for the objects, and R how many we choose every time. So one more time, the difference between permutations and combinations is the order. If order is important, we have a permutation. If order is not important, we have a combination. So this is some information about the permutations. We have it as P parenthesis N comma R. N is the number of objects, and R is the number of arrangements. And this is going to be the formula that we have to use. However, we will use again the graphing calculator. Let's go to see how. Let's clear the previous example. Let's say that we have 3 items and we have to take 2 of them. So we have to go to math, we enter 3, probability, if we have a permutation we go to number 2, enter, and then we take 2 at a time and click enter. So the answer is going to be 6. Let's say that we have 10 items and we want to take 5 at a time. So math, probability, number 2, 5, and then you get the answer, 30,240. Next, for combinations, from the word combination we use the letter C, permutation we use the letter P. So one more time, if we have to take the combinations of 3 objects taken 2 at a time, we have to use C parenthesis 3, 2. And this is going to be the formula, n factorial over r factorial times n minus r factorial. But again, we may use the graphing calculator. Same process. Of course, the answer is going to be different. If we have 3 objects taken 2 at a time, we have to go now to, if order is not important, we have to go to combinations, number 3. Enter 2, and the answer is 3. Let me do exactly the same problem as before. 10 objects taken 5 at a time. Again we go to number 3, we have combinations, 5, enter, and this is the answer. As you remember before, the answer was 30,240 for permutations. Now for combinations, since order is not important, it will be 252. And here I have 2 examples that I would like you to go through them by using the graphing calculator, combination of 8 and 5, combination of 8 and 8. Let's go to see some examples. In how many ways can you choose 5 out of 10 friends to invite to a dinner party? Now, in this case, order is not important. So if you have the friends A, B, C, D, E or A, C, D, B, E, it's the same set of 5 was chosen. So in this case the order is not important, so we talk about a combination. And actually the answer is going to be exactly what I did before. We have 10 friends, a group of 10 friends, taken 5 out of the time. So we have a total of 252 combinations. Now let's do the same problem, but right now instead of having 10 friends we have 10 books on a bookshelf that has space for only 5 books. So in this case, of course, the order is important. Since the arrangement A, B, C, D, E is different from the arrangement B, A, C, D, E or B, C, D, A, E and so on. So in this case we have to use a permutation. Let's do it one more time, even though I used the same numbers before. 10 books, math, probability, we go to number 2, number of arrangements that we need, 5, enter, and this is the answer, 30,240. One more example. In this case, let's go to see how many possible lottery tickets we have to buy to win the lottery. We have a set of 6 numbers taken at a set of 49 numbers. Of course, the order is not important as soon as you have the winning numbers. So we talk about a combination. So we have 49 numbers, same steps. We go to probability, we go to combinations, order is not important, 6. And this is how many lottery tickets we have to buy in order to win the lottery. We have to buy almost 14 million tickets. And actually this is the probability to win the lottery. It's 1 over 14 million, almost 14 million.